Hello and welcome. In this session, we are going to learn about data science in Microsoft Fabric. So, in this lab, we will ingest data, explore the data in a notebook, process the data with the data wrangler, and train two types of models. By performing all of these steps, you will be able to explore the data science features in Microsoft Fabric. So, by completing this lab, you will gain hands on experience in machine learning and model tracking and learn how to work with notebooks, data wrangler, experiments, and models in Microsoft Fabric. So let's get started. The first thing we need to do is create a new workspace. So go on to Microsoft Fabric Home and let's create a new workspace. Let's give data science workspace and scroll down to the advanced section and let's select the license as trial. Click on apply. This will create a new empty workspace. Next thing we need to do is create a notebook. So to run code, you can create a notebook, and notebook provides an interactive environment in which we can write code and run it in multiple languages. So inside the workspace, let's click on create new item. Scroll down. In the prepare data, you will find notebook. Let's select it, and we can also rename our notebook from here. Let's give data science notebook, and what we are going to do is load a sample data set. So in the first cell, which is currently was filled with some jargon data or some jargon information. As you can see, welcome to your new notebook, type code here, etc., etc. What we are going to do is let's first convert this cell into a markdown cell. Let me show you how we can do that. So two hashtags for the heading, and let's give data science in Microsoft Fabric. And on the right hand side, you can see this M and downwards arrow. This converts our cell into a markdown cell. Now let's add a new code cell. So what we are going to do is get the data. So we are ready to run our code to get data and train a model. So here we will be working with a diabetes data set from Azure Open Datasets. And after loading the data, we will convert the data into pandas data frame, which is a common structure for working with data in rows and columns. So inside a new cell, let me give you the code. So this here is the code. So we are first defining a few variables that are blob account name, which is the Azure Open Data Storage account from Azure. Then the container name, which is ML samples, the relative path or the directory which is used for the data, that is diabetes, and it is left blank container for anonymous access. And then we are giving the file path and we are going to create a df using the spark path. Now let's run this. So this will create our df under the name df, and we can either run this small button next to the cell or press shift enter to run the cell, and this will automatically create a new cell for you. So by automatically pressing the run button, it will automatically connect to a standard Spark session for our code to run. And as you can see, it has run successfully. So now let's display the df. So in a new code cell, let's type display df. So let's run this. So this will display the our df and the data we have inside the df that we created, which is the diabetes data set. As you can see, BMI, BP, S1, S2, the sugar levels. So now let's move on to the next cell. So now let me also show you. So there are two tabs at the top of the rendered table we have, that the first one is the table and the second one is chart. So now we can also create some visualizations from this table. So let's select the chart, and here you can see the age with the diabetes. So let's edit it. Let me zoom out so that we can see it completely. Now select start editing. And in here, what we're going to do is change the chart type. So currently it's set at bar chart. We are going to convert it into um, box plot. Do we have a box? Yep, this is the box plot. And inside the now in the y-axis, we are going to change it from age to y. And let's save this. And this is our chart. Now let's move on to the next cell. And what we are going to do now is prepare our data. So we have ingested data and explored the data, and now we can transform the data. So you can either run a code in a notebook or use a data wrangler to generate the code for you. So the data is loaded in a Spark data frame, while the wrangler accepts either Spark or Pandas data frame. So it is currently optimized to work only with pandas. So therefore we have to convert our data to pandas data frame. And how we can do that? So let's move on to the new cell and let's give the code df equals to df dot to pandas, and let's give df dot head. Let's run this. Now we will select the data wrangler. And how to do that? So currently displayed the first 5 columns of our data when converted to pandas data frame. So to select data wrangler, click on the more items option in the ribbon on the top. Now select data wrangler, and this will find the data frames for you. As you can see, there is one pandas data frame because we gave the name as df. If we had given some other name, it will be available as the new name. So now let's select the df data set. When the data wrangler launches, it generates a descriptive view of the data frame in the summary panel on the right hand side. As you can see, the total number of rows, there are 0 missing values. So currently the label of the column is y, which is a continuous variable. To train a machine learning model that predicts y, you need to train a regression model, and the predicted values of y may be difficult to interpret. Instead, we could explore training a classification model which predicts whether someone is low risk or high risk for developing diabetes. So to be able to train a classification model, you need to create a binary label column based on the values from the Y. So now on the data wrangler column, so let's scroll to the extreme right, and here we can see the Y column. So this will also give us the summary of the Y column. So note that there is a decrease in frequency for the 200 to 240 bin. Let me show you. And the 75th percentile is roughly 211.5, which aligns with the transitions of the two regions in the histogram. So let's use this value as threshold for low and high risk. Now, now navigate to the operations panel on the right hand side, and let's expand the formulas, and then we will select the create column from formula. So we are going to give the column name as risk, and risk formula will be, let me show you, this is the risk formula. We are using the f of y if greater than 211.5 as type in. So now let's click on apply, and there will be a new column named risk added to the preview. And scroll down, here you can see there's a new risk column added. So this will show that roughly 25% of all rows, as it is 75th percentile. Now, now select the Add Code to Notebook button in the top ribbon, and here you can see the code is generated. So we can let's cut this code and paste it below the df to pandas. Well, you can run it either way, but it looks a little cleaner. So now let's run this code that was generated by the data wrangler. And here you can see a new risk column has been generated as expected. So now let's run a new command, df underscore clean dot describe. So let's run this. So this will describe our new df, and you can see the count, mean, standard deviation, minimum, 25%, 50%, and the splits, whatever there were. Now what we are going to do is train the machine learning models. So now that we have prepared the data, we can use it to train a machine learning model to predict diabetes. We can train two different types of models with our data set. The first one is a regression model predicting the y value, or the second one is the classification model predicting the risk. So we will train the models using the skitlearn library and track the models using MLflow. So now let's get started with training the regression model. Let me give you the code. So this is the code to train our regression model. So what this does is split the data into training and test data set and separate the features from the label y and gives us the prediction. Now let's run this. Let's wait for it to run. It will take a few seconds. So our code ran successfully. Now let's move on to next code cell and what we are going to do in this code cell. So we are going to create a new ML flow experiment that will be named diabetes-regression. So this model will be tracked in this experiment. Let's run this. Let's wait for it to run and then we will move forward. And here you can see experiment name does not exist, so it created a new experiment and the command ran successfully. Now let's move to the next cell. In this, what we are going to do, so what this code does, it trains a regression model using the linear regression, and the parameters, metrics, and artifacts are automatically logged with the ML flow. So let's run this. Let's also give a simple, here we are going to create a new markdown cell and let's just give regression. This should be fine now, and you can see a new run has been created. Now we are going to train the classification model. So let's give a heading, and let's convert it to markdown. Let's add a new code cell. Now we are going to convert or train a classification model. So we are going to split the data into training and test data set and to separate features from the label that is risk. Now let me give you the code. So this is the code. Let's run this. So this will train our data set and first split it into training and test and then separate the features from the label risk. Now let's move to the next code cell. So this is the next code cell. So we are creating a new ML flow experiment that will be named diabetes-classification. So our model will be tracked in this experiment. Let's run this. And a new experiment has been created. Now let's move on to the next one. So the next code is this. So what we're going to do with this code is it trains a classification model using the logistic regression. Parameters, metrics, and artifacts are automatically logged with the ML flow. So let's run this as well. Next, what we are going to do is explore our experiments. So Microsoft Fabric keep tracks of all our experiment and allows us to visually explore them. So okay, so the code has ran successfully. Now let's navigate to our workspace from the hub in the left-hand side. And here you can see experiments, diabetes classification and diabetes regression both have been created. Now let's select the diabetes regression first and let's wait for it to load. Then what we are going to do is review the run metrics. So scroll down to see the run metrics inside the run details, and you can see training mean absolute error values and all the other training score values. So now let's navigate back to the home page and let's select the diabetes classification, and we are going to review the results of here as well. So let's scroll down and you can see the training score, training accuracy was 87.7%. So note that the type of metrics are different as you trained a different type of model, and also the results will obviously be different. Now what we can do is save the model. So after comparing the machine learning models that we have trained across experiments, we can choose the best performing model, to use the best performing model, save the model and use it to generate the predictions. So as the classification model has an average training score of 87%, and the regression model has an average training score of 55.3%. So we are going to save the diabetes classification model. How we can do that? Select the diabetes classification model from the left-hand pane and select Save as ML model. And then we are going to create new ML model. Let's select a folder. So we have a model folder. Now let's give a name. Let's give model hyphen diabetes, and let's also give classification because that was the name of our model, and let's click on save. Then we will be able to view the model. Let's wait for it to be saved. So our model has been successfully saved. So now let's view the ML model. So here is our ML model that was created from the classification model and with the accuracy of 87%. So note that the model, the experiment, and the experiment link and the experiment run are all linked, allowing you to review how the model is trained. Now let's save the notebook and end the Spark session. So we have finished training our data and evaluating the models. So we can now save our notebook with a meaningful name, or we can download it. So you can rename it from here and then download the notebook as IPYNB or Python notebook. So let's select it. So it will download our notebook as well. So in this exercise, we created a notebook and trained a machine learning model. And we used skit-learn to train the model and MLflow to track its performance. So if you have finished exploring the model and experiments, you can delete the workspace you created for this exercise. And that's all for this session. Thank you. Hello and welcome. In this session, we are going to explore data for data science with notebooks in Microsoft Fabric. So in this lab, we will use notebooks for data exploration. Notebooks are a powerful tool for interactively exploring and analyzing data. So during this exercise, we will learn how to create and use notebooks to explore a dataset, generate summary statistics, and create visualizations to better understand the data. By the end of this lab, you will have a solid understanding of how to use notebooks for data exploration and analysis. So let's get started. Move on to Fabric homepage and let's create a new workspace. Click on new workspace. Let's give any name. Data exploration workspace. Now go to advanced and let's select the license mode as trial. Click on apply. So inside this workspace, we are going to need a notebook. So to train a model, you can create a notebook, and notebook provides interactive environment in which we can write and run code in multiple language as experiments. So now click on new item and scroll down in the prepare data. We will see the option of notebook. Let's select it, and this will create our new notebook. So notebooks have cells, and these cells are used to contain some certain code or markdown. So we can also rename the notebook. Now let's select the notebook and let's rename it. And in these cells, what we're going to do first is let's first give a small heading, and we will convert this cell to a markdown cell. So how to do that? Select this small markdown button and we are going to create a new heading. Now let's click on connect and let's create a new standard session. Then what we are going to do is load our data into a data frame. So now we are ready to run code to get the data. So we will be working with a diabetes dataset from Azure Open Datasets. And after loading the data, we will convert the data into a pandas data frame, which is a common structure for writing the data in rows and columns. So in the new code cell, let me give you the code. And so this is the code. So what we're going to do is use the Azure Storage Access info for the open dataset, that is diabetes. And this blob SAS token is left blank for anonymous access because we are anonymously accessing our data. The next, using the paths, we are going to set the Spark config to access the blob storage. And then what we are doing in the end is creating a DF using the specified path. So we are using the Spark read parquet. So note that it won't load any data yet by now. So we have to run it and then let's run this. So as we have already created a standard session, it will take around a few seconds to load our data. So we can press Alt Enter, or you can just directly click on the Run Cell button next to the cell. Now let's display the DF we have created or the data frame. We will use display DF and let's run this. So we are going to get the data output of our data. So this command will show the complete data in our table or the DF we created. So we have age, BMI, BP, S1, S2, and others. So this output shows the rows and columns of the diabetes dataset. The data consists of 10 baseline variables: age, sex, body mass, index, average blood pressure, and 6 blood serum measurements for diabetes patients, as well as the response of interest, a quantitative measure of diabetes progression 1 year after baseline, which is labeled as Y. Now, the data is loaded as Spark data frame. So, skitlearn will expect the input dataset to be pandas data frame. Now, let's convert our DF into pandas. So, we are going to use a library called skitlearn, and then that library we are going to use for the exploration and visualization. So let's convert our data to pandas because that is the necessary thing for the skitlearn library. So now let's run this. So what we're going to do is df equals to df.toPandas. So we are going to convert our df into pandas, and then we are displaying the first 5 rows of the df using df.head. Let's run this. And this will take a few seconds and we will be able to convert our data into pandas data frame. And here you can see the command executed successfully and it has displayed the first 5 rows in our DF. Now let's move on. So now what we're going to do is check the shape of our data. So we have now loaded the data and we can check the structure of the data set, such as number of rows and number of columns, data type, missing values. So inside a new cell, let's display the shape and columns. So let's use the some print statements. Rows, and what we're going to give here is df dot shape, and in here square brackets we are going to give 0, and let's copy the same thing. Okay, no worries, and we are going to convert rows and let's give it columns, and shape we are going to give here 1 because we want the columns. And then what we are going to give is data type, so let's print the data types as well. Let's also give a line space in here, so \n, again a line space. Let's give data types of columns, and we are going to print df.types. So this will give us the data types of the columns we have. Now let's run this query. Okay, there is an issue. So the issue was because it's actually df.d types for data types, not exactly types. So now let's run the cell again. So here it gives us the information. So the number of rows is 442 and there are 11 columns. And so this means that we have 442 samples and 11 features or variables in our data set. Now so we also get the data types of the columns, age as integer. So the sex variable we getting as integer because sex variable likely contains categorical or string data. So we are getting an issue with that. We're going to change it, don't worry. Next, what we're going to do is check for the missing data. So let's give a new variable, missing data, and then we are going to use df dot is null and dot sum. So this will give us the sum of the total number of values that are missing, and then let's print the missing values. So let's also print a first simple message, missing values per column, and let's print the missing values or the missing data. So instead of missing data, let's change it to missing values. That would be easier to understand. Okay, there is a spelling error. Values. Now let's run this cell. So this code will check for the missing values. As you can see, there are 0 missing values in our data set. Next, what we're going to do is generate descriptive statistics for numerical variables. So let's first get a heading. Generate descriptive statistics for numerical variables. And let's convert it to markdown. Okay, now let's add a new cell. So let's understand the generate descriptive statistics to understand the distribution of numerical values. So the first thing we are going to do is describe our df. Let's run this. So let's look at the values. As you can see, the average age is approximately 48.5 years. and with a standard deviation of 13.1, and the youngest individual is 19 and the oldest here is 79, and the average BMI approximately is 26.37 or 26.4, which falls in the overweight category according to the WHO standards, and the minimum BMI is 18 and the maximum is 42. So now what we're going to do is plot a data distribution. So let's first give the heading, plot data, and let's convert it to Markdown and add a new cell. So what we're going to do is create a graph for our data. Let me get the, and this is the code. What we are doing is importing a few modules or libraries from Python. First one is matplotlib, second one is seaborn, and third one is numpy. So matplotlib is used for uh, generating some graphs. Seaborn is for graphs again, but seaborn is a little bit easier than matplotlib. And then we are importing numpy, which is a pandas library. And now what we're going is calculating the mean, the median of the BMI variable. And this code, what it does is creates a histogram of the BMI variable, and this plt.axv line, this add lines for the mean and median, and then we are going to create a legend and display our bar graphs. Let's run this query. So this will display our graphs. Let's wait for it. And here you can see, let me zoom out a little bit. And here you can see that the most of the BMI fall within 23 point something to 29.2, and data is right skewed. Now let's move on. What we're going to do is perform multivariate analysis. So let's give a small heading and let's convert it to Markdown, add a code cell. So we're going to create a BMI increasing graph. Let's me give you the code. And here's the code. We are going to create a scatter plot of BMI versus the target variable. So let's run this. Let's wait for it. And let me zoom out. So here you can see as the BMI increases, the target variable also increases, indicating a positive linear relationship between these two variables. Now let's add another code block and create another observation. So let me give you the code. So this is the next visualization. So we are creating a box plot for the male and female patients to derive the blood pressure across gender. So let's run this. And here you can see on the result in the bar box plot, we can get on average female patients have higher blood pressure than male patients. And this shows the differences in blood pressure profiles of male and female patients. Now what we're going to do is aggregate the data to make it more manageable for visualization and analysis. Now let's move on to the next code cell and let me give you the, so this is the new and the next code cell. So first what we're going to do is calculate the average BP and BMI by sex using the average values BP and BMI by sex. Now next what we're doing is creating a bar chart of the average BP and BMI by sex. Then we are giving the title and labels. Then using this set of code, we are displaying the actual numbers on the bar chart. And then using plt.show, we are creating our charts. So let's run this code and let me zoom out. And here you can see this graph shows the average blood pressure is higher in female patients compared to male patients. Additionally, it shows that the average body mass index or BMI is slightly higher in females than in males. Let's add another code cell and we are going to create a simple line plot. Let me give you the code. And this is the new line plot code. So let's run this. So this will give us the lowest average BMI values. And let me zoom out so that you can see. And here you can see, okay, let me zoom out even a bit more. So this age group of 19 to 30 has the lowest average BMI values, while the highest average BMI is found in the age group of 65 to 79 years. Additionally, observe that the average BMI for most age groups falls within the overweight range. Now, what we are going to do is create a correlation analysis. So, let me give a let's convert it to Markdown and add a code cell down below it. So let's calculate the correlations between different features to understand their relationship and dependencies. Now let's give df dot correlation and we are giving numerics only equals to true. Let's run this. And now using this data, we are going to create a heat map, and a heat map is a usual tool for quickly visualizing the strength and direction of relationships between variable pairs. It can highlight strong positive or negative correlations and identify pairs that lack any correlation. So to create a heat map into the new cell, let me give you the code plt.figure, and then we are giving the figure size, and let's give 15,7, and then in the new line sns dot heat map, we are using the df dot correlation, and then in here numeric equals to 2 equals to true. So let's run this. Let me zoom out, and you can see S1 and S2 variables have a high positive correlation of 0.89 and indicating that they move in the same direction. So when S1 increases, S2 also tends to increase and vice versa. Additionally, S3 and S4, so this block has a strong negative correlation of negative zero point 0.7. So you can see it's nearly negative zero point 0.7 depending on the color. So this means that as S3 increases, S4 tends to decrease. Now we have finished exploring the data, meaning we can also save the notebook and you can rename your notebook if you need it be. So let's download our notebook as IPYNB. And so in this exercise, we created and used notebooks for data exploration. We also executed code to calculate summary statistics and create visualizations to better understand the patterns and relationship in our data. So if you have finished exploring the model and experiments, you can delete this workspace you created for this exercise. That is all for this video. Thank you. Hello and welcome. In this session, we are going to pre-process data with Data Wrangler in Microsoft Fabric. So we will use Data Wrangler in Microsoft Fabric to pre-process data and generate code using a library of common data science operations. So let's get started with the practical implementation. Go on to the app.fabric.microsoft.com and log in using your Azure credentials. And in here, the first thing we are going to do is create a new workspace. So click on workspaces on the left hand pane and select new workspace. Let's give it any name we want. Let's give data wrangler and let's give workspace in the end. Now scroll down to the advanced section and let's select the license mode as trial and click on apply. Now inside the workspace, we are going to create a notebook. So to train a model, we can create a notebook, and notebooks provide an interactive environment in which we can write and run code in multiple languages as experiment. So in the workspace, click on this new item button and scroll down. In the prepare data option, we have the option as notebook. So select that. So this will create our notebook, and using the notebook, we are going to perform the functions and operations on our data, and the data we are going to use is the OJ sales dataset from Azure Open Datasets. So let's first rename the data, sorry, rename the notebook. Let's give it Wrangler notebook, save it. And in the first cell, let's give a small heading as perform data exploration for data science. And let's convert this cell to markdown cell. This will give us a small heading. Now we are ready to load the data into the data frame. So we are working with the OJ sales or the orange juice sales dataset from Azure Open Datasets. And after loading the data, we will convert the data into a pandas data frame, which is the structure supported by Data Wrangler. So in our notebook, let's create a new cell and let me give you the code to access the storage account as well as the container. And so this is the code we are using. So the first section, we are accessing the Azure Open Data Storage account for the open data set of orange juice sales data, and the container name we have mentioned, and this blob SAS token we have left blank because the container is anonymous access. So after that, we are setting up the Spark config to access the blob storage account path. So we have given a new variable as WASPS path, and we have given the path to access the data. Then we are creating a DF. So this reads the Spark CSV file, and then let's run this query. So before that, we can also create a new standard session. Even if you don't do that, after running the cell, it will automatically create a new Spark session. So let's wait for the session to be created and then we will run this code cell. So and our session has started. So we have two options to run our cell. Firstly, we can just click on the run cell button. Let me show you. And in the next time, I will show you and tell you the second method that will automatically create a new cell after this code cell for ease of use. So since this is the first time you have run any Spark code in this session, the Spark pool will be starting and the first run can take up to or upwards of a minute to complete, and the subsequent runs will be much quicker. So let's wait for it. And our DF creation has been ran successfully. It took around 5 minutes and 26 seconds. Now let's display our DF. So we can just display the first few lines as well. Let's give the first 10 lines and let's run this. So this will display the first 10 lines of our DF. And here you can see, okay, let me show you the proper format. So let's use display DF only. Let's run this. So this will give us a proper table format instead of that comma separated values. Let's wait for it to run. And here you can see our data is here. The next thing we want to do is import pandas and convert our DF to pandas. So me use the query. And this is the query we are going to use. The first is we are importing the pandas and then converting our data frame to pandas and then giving this a sample of 500 and random state 1 and then defining the schema as well. Then using df.head to display the df. Then let's run it. So let's wait for it to run. Then it will display our first few lines of the df and first few lines of the OJ sales data set. Let's wait. Now our convert to pandas query ran successfully and it has displayed the first few lines of our data set that was converted to pandas. Next thing we are going to do is view the summary statistics. So now we have loaded the data and the next step is to process it using the data wrangler. Preprocessing is a crucial step in any machine learning workflow. So it involves cleaning the data and transforming it into a format that can be fed into a machine learning model. So now we have to launch the data wrangler. So let's click on this more items option in the ribbon, select the data wrangler. Now this will fetch our data frames or the DFs and let's select the DF we have created. So when the data wrangler launches, it will generate a descriptive overview of the data frame in the right hand column called summary. It will show us how many rows and columns it has. So let me zoom out so that we can see properly, and it will also show us all the columns. So the week starting, store, brand, quantity, advert, price, revenue, all of these. Let's select the revenue column and let's view the data distribution of this feature. Let me zoom in. So the data type float 64, the 500 rows, 500 unique values, mean and everything. So let's draw some insights from it. So the mean revenue is approximately 33,459 with a standard deviation of $8,032. So this suggests that the revenue sales are spread about over a range of about $8,032 around the mean. Now what we are going to do is format the text data. So we are going to apply a few form transformations to the brand feature. Now in the data wrangler, let's select the brand and this is the brand feature on the grid. This thing is called a grid. So now navigate to the operations panel on the right hand side. Let's select the find and replace and we are going to select find and replace inside this, and what we are going to do is change the old value which is dot or period. Let me show you, zoomed in, and we are going to give a new value which will be space. So now click on, we can also see the results of the operation automatically previewed in the display grid, and here you can see we have converted the, wait a second, let me zoom in, we have converted the dot or the period into space, and let's click on apply. So let's go back to the operations panel and select the format and expand it. Let's select capitalize first character and let's toggle the capitalize all words, and after a few seconds we can apply. So here you can see in the data set all these have been capitalized, with the first letters have been capitalized. Now what we are going to do is replace a few lines. So what we're going to do first is add this code to the notebook. So this will be the clean df. So on the top ribbon, we have an option called add code to notebook. This will automatically add the code to our notebook. And here you can see, let me zoom in. This is the code auto-generated using the data wrangler. So we are going to use this clean df and let's replace the last two lines of this clean df. We are going to change it to df equals to clean data df. So we are going to replace these lines as the code generated in data wrangler does not override the original data frame. And then we are going to run this code. Let's run it. Now let's check the brand variable or the brand column name. So let's just display the brand df brand, and we are going to get the unique values out of it to check if our transformation was correct. Now let's run this. So this should display the values like Minute Maid in capital, Dominic's in capital, and Tropicana in capitals. So now we have learned how to graphically manipulate text data and easily generate the code using the data wrangler. Now we are going to apply one hot encoding transformation. So let's first give a small heading. And let's convert this cell to markdown, and let's add a new cell. So now let's generate the code to apply the one hot encoding transformation to our data as a part of our pre-processing steps. To make our scenario more practical, we will begin by generating some sample data. So this allows us to simulate a real world situation and provide us with a workable feature. Now let's again launch Data Wrangler at the top menu for our data frame. Data Wrangler, let's let it find the data frame. So this will now find the updated data frame. And again, let's zoom out and we will select the brand. So in the brand feature on the grid. So now in the operations, and we are going to expand the formula. So inside the formula tab, we are going to select one hot encode and now click on the apply button to apply the one hot encoding. And here you can see it has updated. Now let's navigate to the end of data wrangler grid and notice that there are a few features that are added. So the new features added are brand Dominic's, brand Minute Maid, and brand Tropicana, and the original brand feature has been removed. Now let's exit the data wrangler without generating any code. So let's go back. Let's exit it anyhow. Now what we're going to do is sort and filter operations. So imagine we need to review the revenue data for a specific store and then sort the product prices. So in the following steps, we will use the data wrangler to filter and analyze the DF data frame. Now let's again launch data wrangler. So let's launch it. Now without selecting any of the grid options, we are going to directly go to operations. And in here, let's select sort and filter. And inside here, we are going to select filter. Now inside the target column, let's add store and operation will be equal to, this thing is called for the operation, and then here we have to give the value which will be 1, 2, 2, 7, and make sure to have this keep matching rows option as checked in. Now let's click on apply and notice the changes in the data wrangler display grid, and here you can see. So now let's select the revenue column or revenue feature and then review the summary on the side. So what are the some insights you can draw from it? So the skewness is minus 0.75, is indicating a slight left skew or a negative skew. This means that the left tail of the distribution is slightly longer than the right tail. In other words, there are a number of periods with revenue significantly below the mean. Now let's go back to the operations. Inside, we are going to select sort and filter. Again, go to sort values. Let's sort the values, and the column name will be price, and we are going to select descending order. So by this arrow, we can select the descending order. Let's apply and let's wait a few seconds. So now in the grid, let's select the price column or the price feature, and let's note the value for maximum. So the highest product price for store 1227, which we selected, is 2.68. With only a few records, it's easier to identify the highest product price, but consider the complexity when dealing with thousands of results. So now what we are going to do is browse and remove steps. So suppose you have made a mistake and need to remove the sort you created in the previous step. So navigate to the cleaning steps panel on the right hand side, and then let's select the sort, and notice that, and also let's delete it. So we can delete a step inside our so notice that the changes have now been reverted back to which were in the filter step. Now let's exit the data wrangler without generating a code. So exit. Next thing we are going to do is aggregate the data. Suppose we need to understand the average revenue generated by each brand. So the following steps we will use to data wrangler to perform a group by operation on the data frame. So let's again launch the data wrangler and select DF. So back to the operations panel, we are going to select group and aggregate. So this is the option group by and aggregate. And in the columns of group by, let's select the brand, not the revenue. Now let's go back, let's add aggregation, and we are going to add aggregation on the column to aggregate property. Select a targeted column. Let's select the revenue feature, revenue, and for the aggregation type, let's select mean. Now let's click on apply. Now let's select the copy code to clipboard, and we are going to exit the data wrangler without getting any code. Now let's in the move back to notebook, we are going to combine the code from the brand variable transformation with the code generated by the aggregation step in the clean data df. So let's move on to the next cell. Let me paste the code and let me edit it. So this is the combined code. Now what this does is replace all instances with period with spacebar in the column brand, then capitalize the first character in column brand and perform the fun aggregation group by on the column brand. Now let's run this. So press shift enter to run and create a new cell. Now let's print the df. So there are various methods to get the df. You can use print df, df.head, and display df. And here you can see it gives the revenue mean for all of our data. So we generated the code for some of the processing operations and copied the code back to the notebook as a function, which we can use to run, reuse, or modify as needed. Now that we have finished processing or pre-processing our data for modeling, we can save the notebook with a meaningful name. So let's give data wrangler pre-processing notebook, and we can also download this notebook as any format we want. So let's download it as ipynb. Download successful. So in this exercise, we created a notebook and used Data Wrangler to explore and pre-process data for our machine learning model. Now that was all for this lab. You can delete your notebook as well as the workspace to save resources. And thank you so much. Hello and welcome. In this session, we are going to train and track machine learning models with MLflow in Microsoft Fabric. So we will train a machine learning model to predict a quantitative measure of diabetes, and we will train a regression model with skitlearn and track and compare our models with MLflow. So by completing this lab, you will gain hands-on experience in machine learning and model tracking and learn how to work with notebooks and experiments and models in Microsoft Fabric. So let's begin by creating a workspace. On the left-hand pane in Microsoft Fabric, create a new workspace. Let's give it train and test workspace. And in the advanced section, let's select the license mode as trial. Let's click on apply. Now inside our newly created workspace, we are going to create a notebook. So to train a model, we can create a notebook, and notebooks provide an interactive environment in which we can write and run the code in multiple languages. So let's select a new item, scroll down, and let's select our notebook. This will take a few seconds to load our notebook, and here you can see our notebook has been loaded. Now let's collapse the Explorer and let's give a small heading before starting with our training model. So let's give train uh, machine learning model and track with MLflow. And let's convert this cell to a markdown. Now what we are going to do is load data into a data frame. So we are ready to run our code and get data to train a model. So we are working with diabetes dataset from Azure Open Diabetes dataset. And after loading the data, we will convert the data into pandas data frame, which is a common structure for working with data in rows and columns. So let's add a new cell, code cell, and we are going to use the Azure Open Storage account for the diabetes dataset. So let me give you the code. And so this is the code. We are using Azure Storage Access info for the open dataset of diabetes. And we have left the blob SAS token as blank because since the container is anonymous access, then here we are setting up the Spark path. So we set the Spark config to access the blob storage, and then we are setting the df and creating the df to read the parquet data. And note that it won't load any data yet by now, so it will just create a df. So let's also connect a new standard session. So a standard session or standard Spark session is needed to run all our machine models. So any code we need to run needs a compute service. So the standard session creates a compute service for that. Let's wait for the session to be created, then we will run our code. So press Shift Enter to run the code and move to the next cell. So this will take a few seconds to run the code. Let's wait. So since this is the first time you have run any Spark code in this session, the Spark pool must be started. And then this means the first session can take around a minute, but it completed in 11 seconds. That's even better. And the subsequent sessions will also be even quicker. Now let's move to the next cell and display our DF that we created. So we will use display DF command. Let's run this. So this will show our data that was in the Azure Open Datasets and now converted to DF for our notebook. Now the data has been loaded into the DF and we are going to use Spark data frame and use skitlearn to expect that input data to be pandas data frame. So let's convert our data frame into pandas. So let's import pandas as PD, import pandas as PD is okay, not just PD. And then we are going to give df equals to df dot to pandas, and then let's display the first few lines using df dot head. Okay, we do not need 0. Let's run this. So this will import pandas library and use the variable as pandas pd. And then we are going to convert our df to pandas and then display the first 5 lines. So this displays the first 5 lines of our pandas df. Now what we're going to do is train the machine learning model. So let's give a small heading, train machine learning model. Let's convert it to markdown. So now that we have loaded our data and we can use it to train a machine learning model and predict a quantitative measure of diabetes. So we are training a regression model using the skitlearn library and track the model with MLflow. So let me give you the code first. And so this is the code we are using. So what this code does is this code snippet is performing a common operation in machine learning, that is splitting a data set into training and testing subsets. So let's break it down. So here we are importing a sklearn.model selection. So we are importing the train test split function from sklearn model selection. This function is used to split your data into two parts, one for training the model and the other one for testing the model. Then we are defining the features and target variable x and y. Here you can see. So x is the feature matrix which contains the independent variables or the input data for the model. Here it's taking multiple columns from the data frame df that are age, sex, BMI, blood pressure, etc. The values convert the data frame into a NumPy array, and y, the y we are creating is the target variable for the output we are trying to predict. So in this case, it's the column y from the df. And the next thing we are going to do is splitting the data. So x and y, or x train and y train, are the training data, features and target variable that will be used to train the model. X test and Y test are the testing data, features and target variable that will be used to evaluate the model's performance. And the test size is zero point 0.3. This means that 30% of the data will be used for testing and the remaining 70% will be used for training. You can change this to adjust the size of your train or test split. The next is random state 0. This is a seed for the random number generator. Setting a specific value ensures that the split is reproducible. So if you run the code multiple times with the same random state, you will get the same train test split. So in summary, this code is splitting your data set or DF into a feature matrix that is represented by capital X and a target vector represented by small y. It then divides the data into training and test sets, which are 70% of the data will be used for training and 30% for testing. This is a common approach to ensure that your model is evaluated on unseen data, that is the test set, which helps in assessing how well it generalizes to new data. Now let's run this code cell. Okay, press Shift Enter. It will take a few seconds to run, then we will move forward. Let's wait for it, and it has ran successfully. Now we are going to create an ML flow experiment. So let's import ML flow in a new cell, and we are going to give the experiment name. Let's go name equals to experiment. We can give any name we want. That's BTs, and then we are going to use ML flow dot set experiment, and in here we are going to give the variable experiment name. So what this code will do is create an ML flow experiment named diabetes, experiment diabetes, and our model will be tracked in this experiment. Let's wait for it to run, and then what we are going to do is train a regression model using linear regression. So it has run successfully. A new experiment with the experiment name has been created. Now let's move to the next cell, and we are going to import linear regression, and let me give you the code. And this is the new code. So what this code will do is train a regression model using linear regression. The parameters, metrics, and artifacts are automatically logged with the ML flow. And additionally, we are logging a parameter called estimator with the value linear regression. So let's run this, and let's wait for it to run. The next, we are going to train the regression model using decision tree regressor. And let's wait for the code to run. And it has ran successfully, and you can see a random run name under the experiment name experiment diabetes has been created. Now let's move to the next cell, and this is the new code. So what this code will do is train a regression model using the decision tree regressor. Parameters, metrics, and artifacts are automatically loaded with the ML flow, and additionally we are logging a parameter called the estimator with the value decision tree regressor. Let's run this, and let's wait for it to learn. And after that, what we are going to do is use ML flow to search and view experiments. So let's give a small heading. ML flow to search and view experiments, and let's convert it to markdown. Okay, at least you should be capital. And let's add a new code cell. So we have finished training and tracking models with ML flow, and we can use the ML flow library to retrieve our experiments and the details. So let me give you the code. Let's first import ML flow, and experiments equals to ML flow dot search experiment, sorry, ML flow dot search experiments. Now for experiments, we are going to print the exp.name. Now let's run this cell. Now to retrieve a specific experiment, we can get it by its name. So we have experiment diabetes as output. So let's get the information about the specific experiment. Let me give you the code. So this is the code. Let's run this. And here you can see the exact information: artifact location, creation time, ID, life cycle stage, etc., etc. Now using an experiment name, we can retrieve all the jobs of that experiment. Let me give you the code for that. mlflow dot search runs, and then we are going to give exp dot experiment ID. Let's run this. So here you can see the run ID, experiment ID, and all the jobs that ran in that experiment. Now, to more easily compare job runs and outputs, we can configure the search to order the result. For example, let's search for the results by start time, and let me give you the code ml flow dot search runs and then exp dot experiment id, and then we are going to give order by. Let's give the order by as start underscore time space description. Okay, not this, comma max results. Okay, max results equals to 2. Let's run this. So here we are giving, or the following cell orders the result by start time and only shows a maximum of 2 results. Now, finally, we can plot the evaluation metrics of multiple models next to each other to easily compare the models. So let me give you the code for that as well. Now, this is the code. We are going to plot a bar graph. Let's run this. So here's the comparison of the models. So decision tree regressor and linear regressor and the R2 scores for those. Now we have completed with the ML operations, so we can explore the experiments. So Microsoft Fabric will keep track of all your experiments and allow you to visually explore them. Now let's navigate to the workspace on the left hand side, and let me zoom out a little bit. And here we have the experiments that was named under the experiment diabetes. So if you do not see, make sure to refresh the page. Now let's wait for it. Now navigate to the view tab on the top and let's select the run list. And here you can see there will be 2 latest runs which are given random names. So these 2 last runs will be compared to each other. Let's select both of these, and here you can see the comparison of both of these runs in graphs. So let me zoom out so that we can see the proper score. So the last 2 runs are compared to each other by metric comparison. So we can also compare the trainings as well. Now, let's edit the graph representing the training mean absolute error. So let's click on this edit button. Now let's change the visualization type from line graph to a bar chart, and change the x-axis from run name to estimator, and select replace, and as you can see it has been converted. Optionally, you can repeat these steps for the other graphs in the metric comparison pane. So by plotting the performance metrics per logged estimator, you can review the algorithm resulted in better model. Now what we are going to do is save the model. So after comparing machine learning models that we have trained across the experiment runs, you can choose the best performing model to use the best performing model, save the model and use it to generate the predictions. Now go to the run details in the view tab, and let's take the R2 score or the training R2 score of each of these models. So the model with the name Wheat Nest has an R2 score of 0.73, and let's check for the Bright Sponge, and it has a R2 score of 0.5. So make sure to select the model that has the higher R2 score, and you can see the Wheat Nest has the higher R2 score. Now select the save, and you can see the option save run as an ML model. Select create new model, and let's select the folder as model, and let's give the model a name. Let's give model diabetes, and let's click on save. After the model has been saved, we can view the model. This will give us the notification, will give us the option to view the ML model. Let's view our ML model. And here you can see we have the ML model, and this has all the information we use. So the 0.73 and all the criteria and everything is present here. So note that the model, the experiment, and the experiment run are all linked, allowing you to view and review how the model is trained. Now let's save our notebook and end the Spark session. So let's go back to our notebook, and let's give our notebook a name. Let's give diabetes notebook, compare models, and let's save it. And let's also download the notebook for further future use. Now, in this exercise, we created a notebook and trained machine learning models, and we used skitlearn to train the model and MLflow to track its performance. Finished exploring, make sure to delete your workspace, and that's all for this session. Thank you. Hello and welcome. In this session, we are going to generate batch predictions using a deployed model in Microsoft Fabric. So we will be using machine learning model to predict a quantitative measure of diabetes data. And by completing this lab, you will gain hands-on insights and experience in generating predictions and visualizing the results. So let's get started. Go on to app.fabric.microsoft.com and let's create a new workspace, and let's give it a name, deployed model workspace. Now go to advanced section and let's select the license mode as trial. Click on apply. And the first thing we need to do inside this notebook is to create a notebook. So let's go on to new item and scroll down into the prepare data option. We have the option of notebook. So let's create a new notebook. Let's wait for the notebook to create. Let's collapse the Explorer pane, and the first cell of the notebook, let's give a small heading like, and let's convert this cell to a markdown cell. Now let's connect a new standard session. So the standard session is a compute session necessary for running all the codes inside our notebook. So the first step we are going to do is train a machine learning model. So we are training a machine learning algorithm or model that uses a regression algorithm to predict the response of interest for the diabetes patient, a quantitative measure of diabetes progression 1 year after the baseline. And okay, there's a spelling mistake. No worries. So let me give you the code for importing the necessary libraries, getting the data, splitting the features, and according to a 30-70 split, then training the model in an MLflow experiment, defining the model signature, and log the model. So this is this will be the code. So first we are importing some important libraries, then we get the data from Azure Open Data Storage, and the data is diabetes data. Then we are defining a DF and then converting it to pandas. Then we are splitting our data for training. Then we train the model in MLflow experiment, and then we define the schema, and then we log the model into a new model name and save it. Now let's run this code. This will take a few minutes to run, so let's wait for it. And let me tell you what we are going to do next. So We are going to register the model that is being trained right now in the next step, and then we will create a test data set in our lakehouse. So let's wait for the model to be trained, then we can save it. So let's wait. And here you can see our model ran successfully and it also created a run. Now what we are going to do is use the most recent experiment run and register the model that was trained in that run. So let's run this. This will take a few seconds. So this will now save our model in a workspace that will be named diabetes-model. Optionally, you can use the browse feature in your workspace to find the model in the workspace. And let me show you that as well. So let's open a workspace. And here you can see the ML model is present. Let me expand the type. So the ML model is here. Now let's go back to our notebook. So now what we are going to do is create a test data set in a lakehouse. So to use a model, we are going to need a data set of patient details for whom you need to predict diabetes diagnosis. So we'll need to create a data set as table in the Microsoft Fabric Lakehouse. So let's expand the Explorer pane. And here you can see we have the option of Lakehouse. So let's add a new lakehouse. We can select new lakehouse, click on add. Let's give it any name, diabetes data. Let's create the lakehouse. So let's wait for it. And it will give us the option to stop the concurrent session to save our resources in the notebook. So let's stop it. And so our lakehouse has now been created. So what we are going to do is attach it to our notebook, and it was attached. So as you can see, lakehouse 1 items added. So it means that the lakehouse has been attached to our notebook. So what we're going to do now is add a new code cell and create a data set and save it in the table in the lakehouse. So let me give you the code. And this is the code for our data set. So we are creating a new data frame with the patient data and then converting the data types to match the model input schema and then save the data in a data table. So let's run it. So let's wait for the table to be created inside our data. First, it will start a new standard session, then it will move forward. Now our table has been created. So let's explore the table. Let's go to lake houses, tables. Currently there is nothing. So let's refresh. As you can see, a new diabetes test table has been created. We can also view its schema as the schema we defined. Now what we're going to do is apply the model to generate the prediction. So we can use the model we trained previously to generate diabetes progression predictions for the rows of the patient data. So let's get the code. And this is the code for our generate prediction. So the first thing, this df test, what this is doing is it is reading the patient features data, and then model equals to ml flow transformer. What we are doing here is using the model to generate diabetes predictions for each row, and then in the end we are saving the results, so the original features plus the prediction. Now let's run this cell and let's wait for the predictions to be created. Now let's view the diabetes test table that we have. So let's go to tables. Let's refresh it before that. And now we will be able to see a new field that will be named predictions added to it, as you can see. Now what we're going to do is view our diabetes test. So how we can do that? Just drag the diabetes test and onto a new code cell and let's run it. Let's wait for it to run. It will show the first 1,000 rows. And here you can see the new predictions column has been added. So in this exercise, we used a model to generate batch predictions and then we displayed the data. So after you have finished exploring, you can delete the workspace that you created for this exercise. That's all for this video. Thank you.